I'm starting my topic on track tolerances. As we are aware that we have to maintain track, as per laid down standards to ensure safety as well as comfort. In order to have perfection or desired level achieved in track maintenance, we need to have some limits within which we should maintain it, because we can't maintain track to a perfect level. We can't maintain everywhere gauge as -3, twist at 0, or cross level at 0, or alignment as per design value. It's not possible practically due to many reasons, due to maybe our track components are defective, maybe formation is defective, maybe ballast is insufficient, maybe loading is improper. So there are many reasons. Otherwise, wear and tear is there. So these things lead to deterioration of track, and we cannot maintain it to perfect level. So we need some limit within which we should maintain it. So that's why we have been given with tolerances within which we have to maintain the track in the PV manual. So today's class is about what are various tolerances which have been laid down in PV manual and where are those available. Before entering into actual value of tolerance, let's understand what is the reasoning behind this, why this is required. All those things we will first understand, first we will discuss, and then we will go into actual tolerance values. Okay? Okay? Sir. So first of all, let's see brief of track geometry and track vehicle interaction, how track defects is going to affect our vehicle movement, and what are the salient features of track geometry which we need to maintain. If we don't maintain, what is going to happen? So as we can appreciate that the main function of our railway track is to transfer the loads coming from the moving trains or rolling stocks to the formation, and also provide a guidance to the movement of the track, movement of the vehicle, whether it has to go on a curved alignment, whether it has to go in line number 1, line number 2, line number 3. These things are guided by track only, and the main function is to transfer the load. While performing this function, the responsibility of track is to permit safe movement of rolling stock. There should not be any unsafe condition, and parallelly we have to also ensure that there is not much discomfort to the passengers who are traveling in our train. So these are our basic duties, if you understand, by when we are maintaining a track or constructing a track or laying a track. This is our main duty. And track performance, how our track is performing, that is mainly judged by the riding comfort. Otherwise, safety the prime issue hai. If any unsafe thing happens, then your entire performance goes down. But otherwise, if everything is okay, then what is the riding comfort, that decides. And that riding comfort depends on not only on track, it depends on track geometry parameter, it depends on vehicle design parameters, and it also depends on the operating features. What are the operating features? What is the gradient? What is the curvature? Then what type of loco is there? What type of couplers are there? All those things affect overall riding comfort. But we, as far as civil engineers are concerned, we are concerned with this part, and we have to ensure that we don't contribute into unsafe condition as well as poor riding comfort. That is our duty as a civil engineer. So accordingly, we have to maintain our track within the laid down limits as close to perfection as possible. But as I discussed, it's not possible to lay down to keep a track in a perfect condition. We can maintain only in certain laid down limits. Okay. So what are various types of defect? All of you are aware. Being a civil engineer of railway, all of you are aware. The gauge can be defective, the cross level can be defective, there may be unevenness defect, there may be alignment defect, and there may be what you call twist. So these are the defects which we want to keep within the limits. So gauge defect is also somewhat related to your unevenness, and cross level is also related to unevenness and twist. So these are generally linked but not directly related. Linked है आपस में, but ऐसा नहीं कि cross level out हुआ दो. If at two places cross level are out in same direction, you will get no twist. So generally we will get, when cross level defects are there, we will get twist defect also. But it may happen that only cross level defect is there, or only gauge defect is there. There is no alignment defect. So this may happen. As far as riding is comfort, these two parameters are very important. राइडिंग के लिए ये ज्यादा क्रिटिकल है, अनइवननेस एंड अलाइनमेंट. हाउएवर सेफ मूवमेंट एवरीथिंग इज इंपॉर्टेंट. लेट इट बी गेज डिफेक्ट, लेट इट बी अनइवननेस डिफेक्ट, लेट इट बी अलाइनमेंट डिफेक्ट और लेट इट बी ट्विस्ट डिफेक्ट. फॉर सेफ मूवमेंट ऑल these parameters are important, but as far as if track is within the safe limit, unevenness and alignment, these two parameters are very much important for good riding comfort. And that's why when you will see maintenance tolerances, we will see at few places only tolerances for these things have been lent. That is the reason. Okay. If anybody has any question in between, please ask. Okay. Now, once there is any defect either in track or in rolling stock or in operating features, vehicles will be subjected to oscillations, or we may call it accelerations. So those acceleration is going to affect movement of our vehicle. What kind of effect it can be? You can see it. The vehicle is free to move in all the three axes. It can move about longitudinal axis, that is x-axis, in the direction of motion. It can move horizontally perpendicular to the direction of motion. Move means oscillate. It cannot move, it cannot go beyond certain distance, but it can oscillate. Provision is there. And similarly, it can oscillate vertically upwards. So all these movements come through, number one, due to design feature of the rolling stock as well as track. Number two, due to defects in the track and rolling stock. And number three, due to operating features. So these things contribute to overall oscillations in this direction. Otherwise, movement is affected by loco in longitudinal direction and brake in longitudinal direction. This is the input we are giving, loco and braking. All other movements, whatever is happening in the rolling stock, is a consequence of either track and number one, the design parameter of track and rolling stock. Number two, defects in track and rolling stock. Number three, defects in, or what you call irregularity in operating features. So what kind of movements happen? Let's see it. If the rolling stock is oscillating in the direction of motion, I mean longitudinal axis or x-axis, that movement is known as settling. ठीक है, इसको हम लोग बोलते हैं settling. Loco is applying the tractive force or brakes are being applied to stop the movement. So in this direction, whatever oscillation takes place, that is known as settling. And you can appreciate that this can be mainly due to this operating parameters. Like loco applies sudden brake, or loco applies sudden hauling power, और sometimes rolling stock में कोई defect है उसके couplers में. All these things can only result in this. Track will not contribute in this except in gradients. अगर आपका track gradient में है, then we will contribute into it. Otherwise, we are not going to contribute. I mean to say that track defects are not going to contribute. Track design parameter, if our track is in gradient, then certainly we will contribute in it. Otherwise, operating features and some rolling stock defects like couplers defect can mainly affect this movement. So this movement is known as settling movement. Okay? Then second, you can see lurching. This happens perpendicular to the longitudinal axis, along y-axis. Ajay Kumar.
Good morning, sir. Yes, sir.
Why this movement should happen? We are not giving any input in longitudinal lateral direction. Why this movement should happen?
Due to sir cross level, sir. Difference in cross level, sir.
It will mainly happen due to alignment defect. Track में कोई alignment का problem है तब होगा, ठीक है ना? Number one. Number two, we have designed our rolling stock and track in such a way that vehicle can oscillate in between. By design only we have allowed it. So these are the two basic reasons for this movement, not due to cross level. Okay. Then third is bouncing. Bouncing means track will
Load packing.
Certainly लूज पैकिंग से भी हो सकता है. Then कोई आपका uneveness defect है, that will also contribute. And then if any defect is there in the rolling stock, like suspension system में problem है या सस्पेंशन सिस्टम में प्रॉब्लम है या उसके कुछ कनेक्शंस में प्रॉब्लम है जो वर्टिकल रेस्ट्रिक्शंस दे रहा था, those things can result into this bouncing motion. ठीक है ना? Now, these are the translatory motions, translatory oscillations which are possible in rolling stock during movement of rolling stock. Some rotational movements are also possible. We can see it. If the vehicle is just a minute. If vehicle is rolling about x-axis, rolling means it's rotating about x-axis, then that is known as rolling. And what does rolling means? Let's see it. This is rolling, in which rolling stock is rotating about longitudinal axis. And why this can happen? You can appreciate mainly due to cross-level defects. If cross-level defects are there, or any defect in the suspension system of rolling stock is there, और vehicle के diameters में कोई फर्क है, then only this movement will be possible. This oscillatory movement is possible. Then if it is rotating about y-axis, that is known as pitching, and this you can appreciate, this is pitching movement. Why this will happen? Again, if track is uneven at certain location, like कहीं पे इस तरह का unevenness है, then this will result into such kind of movement, pitching. And then last one is nudging, in which our rolling stock rotates about vertical axis. This is x-axis, this is y-axis, and this is z-axis. So it's rotating about z-axis. And why this will happen? Mainly due to alignment defect in this direction. So these are all what you call oscillations possible in case of our track defects or rolling stock defects or operating feature, or sometimes due to design parameter itself. So these movements are possible. Ultimately, all such oscillations are going to give some level of discomfort to the passenger. But we have to keep these within the tolerable limit so that it is not experienced, the jerk is not experienced by the passengers to a discomfort level. That is our duty. So now we will see what defect is related to what. Unevenness, you can see unevenness will give vertical acceleration. Accordingly, vertical right index value will increase, and it will also have safety effect because it will lead to offloading and unloading of vehicle. Offloading of vehicle means offloading of wheels, we can say, not vehicle. Offloading means, can anybody explain what is offloading? You see, this is one bogie and this is another bogie over which rolling stock has been kept. Now this bogie contains 4 wheels and this bogie also contains 4 wheels. Suppose track at this location is somewhat down compared to these locations. What will happen? The wheel at this location will, जो spring है यहाँ पे, the spring with attached with this wheel will get elongate, and once it elongates means load being carried by this wheel and accordingly diagonally opposite wheel will get reduced. So this phenomena is known as offloading of wheel. And simultaneously these 2 wheels will get onloaded. So as far as onloading is concerned, no safety issue is there, but wheel offloading has a safety issue. If wheel gets offloaded, then derailment condition happen. Derailment situation may come because as per charted, it was established that vehicles can derail without any lateral load if there is an offloading up to the extent of 65%. If this wheel was carrying, say, 10 ton, 12 ton load, 11 ton load, and out of this 11 ton, 6.6 ton offloaded, then this may lead to a condition where derailment may happen without any lateral force. Lateral कोई defect नहीं है, फिर भी हो सकता है. So this is very important कि unevenness may result into derailment also in case of severe offloading of the wheel. Then alignment, as we can appreciate, alignment defect will give lateral acceleration and accordingly will increase the lateral line index, and this defect will increase the derailment force. So unevenness on one hand is increasing the offloading, which can create a situation where wheel can get offloaded without lateral load. Parallelly, alignment, what is doing? Alignment is increasing our lateral forces. So if these two defects are simultaneously happening, means we are increasing further derailment proneness of the rolling stock. That twist only result in offloading and onloading. This does not have direct impact on what you call riding comfort. Riding comfort पर directly related नहीं है, whereas we see here unevenness and alignment affects riding comfort also. These are two parameters which are related to riding comfort, and these are two parameters which is related to safe running. So in this way we can correlate that what defect can cause what kind of discomfort or unsafe condition. Of course, gauge is covered in alignment defect. If there is gauge defect, generally it will also cause alignment defect. So this is all. What are the effect of various defects on our rolling stock safety and rolling stock comfort? Okay, ठीक है? ADN SRE, you are back or? ADN SRE.
Yes, sir.
आ गए? कहाँ थे आप?
कॉल ऑफिशियल कॉल आ गया सर।
क्लास पे रहते समय क्लास पे रहिए तो अच्छा होगा। SRE means what? कहाँ पे हैं आप?
सर सहारनपुर सर myself आदित्य एडीएन सहारनपुर अम्बाला डिवीजन नॉर्दर्न रेलवे।
नॉर्दर्न अम्बाला सहारनपुर, रुड़की सहारनपुर है ना?
यस सर।
जहाँ सारी ट्रेनें रात में ही रुकती हैं।
हेलो जी सर।
अभी
हेलो सर।
हाँ जी।
हेलो ये सर अनइवननेस का एक बार बताएंगे ऑफलोडिंग वाला।
Unevenness, you see,
ऑफलोडिंग वाला
बता रहा हूँ। These are two rails, ठीक है? Say this rail is little bit down here. Now your four wheels are moving on one bogie. पहले जो पुराना बॉगी था उसमें तो पुराने रोलिंग स्टॉक में तो बॉगी कंसेप्ट नहीं था, बट अभी वाले में बॉगी कंसेप्ट है. तो व्हाट विल हैपन, दिस व्हील, द स्प्रिंग्स एट दिस व्हील विल गेट लिटिल बिट रिलैक्स्ड. जैसे ये डीप में आएगा क्या होगा, दिस व्हील विल गेट रिलैक्स्ड, दिस स्प्रिंग विल गेट रिलैक्स्ड और नॉट.
यस.
Once the spring has been relaxed, spring क्या कर रहा था, spring by the way of its deflection taking that load, you have relaxed the spring, means it will take now lesser load. And आप एक टेबल का कंसेप्ट देखिए, this is a table kept on floor. Now you cut one leg, what will happen, you cut one leg by say 1 feet, या उसके नीचे की जमीन को आप गड्ढा कर दीजिए 1 feet, क्या होगा, it will start rocking about this axis like this. ठीक है ना. Same thing will happen here, but since it is spring loaded, spring will still keep the wheels on track. अगर स्प्रिंग नहीं होता तो wheel could have hanged, due to wheel could not have negotiated this deep, वो सीधा हैंग हो जाता. Like in this condition, जहाँ पे टेबल में कोई स्प्रिंग नहीं लगा है, तो what will happen, one of the wheel will remain in air, it will not touch the ground once you have cut the leg. Now due to spring what will happen, this will come down, but once it has come down, it will also affect the load coming on this diagonally opposite wheel. So whatever load reduction is there, say मान लिया स्प्रिंग डिफ्लेक्शन पहले 10 सेंटीमीटर था, now due to compressed spring जो था उसकी हाइट 10 सेंटीमीटर थी, due to this twist or due to this unevenness or due to this dip in rail, say now it has become 12 centimeter. So we can appreciate that the load taken by 2 centimeter deflection of spring will be offloaded for this wheel, and once it is offloaded, it will share this offloading with this wheel. So what will happen, equivalent load corresponding to 1 centimeter deflection of spring will be offloaded here, and 1 centimeter of deflection of spring will be offloaded here. So in this way, these two wheels will be offloaded by 1 centimeter deflection की equivalent जो load था, and the same load तो कोच का load या rolling stock का load तो change हुआ नहीं है, load is same. तो balance load जो इधर घटा, that will be shared by these two vehicles. So in turn, what will happen? These two springs will be relaxed by 1 centimeter, and these two springs will be compressed by 1 centimeter. So accordingly, extra load will be taken by these two spring loaded wheels, and less load will be shared by these two spring loaded wheels. Is it clear?
Yes, sir.
Okay.
Yes.
So this was just to explain you that what parameters affect which thing. Sure. Why do we measure our track? As a track maintenance engineer, it gives us what you call it gives us to judge what kind of performance we are making in track maintenance, or what kind of input we are giving the track maintenance, or what kind of input is still required in the track maintenance. So that is the purpose. And what are the defects that we find out, which parameter is defective, up to which level it is defective, and then we compare those track defects or track parameters with standard to evaluate in which category our track lies. We also monitor through successive measurements that what is the rate of deterioration, for if any special attention to that area of track is required or not. Like at every measurement we find that curve alignment is getting affected. Then we must examine that क्या कोई formation problem है, क्या यहाँ ballast नहीं है. Accordingly we will plan the input. तो जो chronicle degradation हो रहा है या time के साथ बढ़ता जा रहा है, all those things we check, and in turn we give timely input to prolong the life of asset and quality of asset. So these are overall requirement of measurement. This you can appreciate, nothing more to explain. If you don't measure it, you will not be able to judge or evaluate your performance and your what you call maintenance inputs. And साथ के साथ क्या comfort level में आप हैं, किस track standard को आप maintain कर पा रहे हैं, those things cannot be judged unless and until you measure your track. So same thing again explained through a chart. The purpose of monitoring track quality and performance is to know where maintenance inputs are required and when maintenance inputs are required. This is the purpose. And so when and where is desired, so that we can put optimal use of maintenance inputs. We need not waste our machine, we need not waste our manpower, we did not touch our track if it is not required. So that is the purpose, and in turn what we are getting, safety and comfort we can achieve otherwise also by giving too much of input, that we can achieve, but that will not be economical. So purpose of recording measurement or keeping some tolerances, deciding some tolerances, measuring the quality of track is to ensure safe, comfortable and parallelly economical transportation. So that is the purpose of measurement and साथ के साथ let down tolerances to judge. Now in our system we do manual inspections and mechanical inspection. So manual inspection के क्या methods है? We do foot inspection, we do push trolley inspection, and sometimes we judge riding of our track section through foot plate or brake. So these are the manual inspection. But the problem, manual inspection में हम करते क्या है? Track parameter measures करते हैं, unevenness, alignment, cross level gauge and lateral jerk or vertical jerks. But some problem is there when we do manual measurement. We can see it. It is subjective. Say I have foot plated one section, I will say track parameters are okay except only 2 locations need attention. Whereas on same loco, if somebody else moves, he may say that we need at 8 locations. So the judgment of measurement, judgment about overall quality of track in case of manual measurement is subjective. It's not a mechanical, so that it's not a mechanical feature that will give uniform result every time. Even if same person is doing foot plate 2 times, 3 times, his observation may differ depending upon his keenness, depending upon his alertness, depending upon other features in what sort of mind he is. So that is subjective. Under manual measurement, whatever parameter we measure, we measure in floating condition only. Floating condition means, what do you mean by floating condition? कोई बताएंगे floating condition क्या होता है?
Without loading condition.
Without any load.
Without
any load.
Track is simply laid, ऊपर में कुछ भी नहीं है. And we know that when we put load on the track, it is going to deflect little bit due to dead load as well as some oscillatory movements are there. Those will also affect. Then some dynamic loads are there. Those things will also affect. So we don't get actual measurement which track will be subjected to when loads are moving. In manual measurement, this is the problem. What we get floating condition when there was no load. But under loaded condition, these parameters may change a little bit. जो आपका error है, that is bound to increase by some margin under loaded condition. It is time bounding and that is okay. We can't keep continuous record of track geometry because we cannot maintain uniform track. हर बार पुश टॉली करेंगे, सेम लोकेशन का मेंटेन करके लिखेंगे कहाँ क्या डिफेक्ट मिला, कब रिस्टोर हुआ, फिर क्या है, तो थोड़ा डिफिकल्ट वर्क है. We cannot do it. So since we cannot do keep continuous record of track geometry, we cannot make detailed analysis also. And in such a way, the modern track structure, which is subjected to very high load and very high speed, is not inappropriate for maintenance as per manual measurement. Maintenance inputs as per manual measurements, and that's why we do mechanical measurements on our track, and we are doing it right now also. It's not a new system. We have TRCs, we have OMS, we have oscillograph cars which give mechanical observations. As you can see, the mechanical parts are does not depend on their psychology. Whatever machine condition is there, it will give uniform result for uniform defect unless and until that machine becomes defective or we don't calibrate the machine. If we have done so, it is bound to give objective output about the track quality, and we do it by track recording cars, which is maintained by track machine and monitoring directorate of RDSO, which is under control of engineering department. TRC cars, generally we run TRC car on all the sections, but in some high speed sections where TRC of high speed are not available, we also evaluate our track through oscillograph car. But this car is under control of mechanical director of RDSO, and then regular monitoring we do through OMS or oscillation monitoring system. This system is available with all divisional or zonal headquarters. This is small machine which is kept on a loco or brake van, and then accelerations are observed. सिर्फ acceleration observe करते हैं. इसमें कोई we don't get any track parameter as such, but we get overall effect of those defects, whatever may be there in the track, but we get the effect of effect in terms of acceleration. Advantage, as we discussed, objective. It will not depend upon generally mood of the machine. If you have calibrated, it will give proper result. Measurements are taken in loaded condition. This is very important because we are able to know, we can know it that what is the track behavior when load is moving at a particular speed. So that we are knowing. Since it's mechanical system, due to vast computerization, now systematic recording can be done, and the track defects, deterioration or input given or further improvement, everything can be kept on record. Better data analysis is possible through this. Fast and convenient, continuous record of track parameters, and less human intervention. Human intervention is limited to the extent of calibration of those machines. If calibration we don't do properly, then everything will go in waste. That is okay. But once we have calibrated the machine, we will get better output in case of mechanical measurement. The mechanical measurement, when it is being done, we are judging our track quality based on two criteria. One is peak based, another is standard deviation based. Peak based means actual value of track defects. Say our gauge is +10, alignment defect is -5. Unevenness is something, twist is something. That exact value, क्या track में defect under loaded condition, that exact value will be given, and it is helpful in identifying the location where this defect has happened. So this is say 1 kilometer section. So at this location, this is the defect. It will clearly give you. So this is peak based observation, and it is with respect to absolute value of that parameter. and it is used on Indian Railways for isolated attention. Where standard deviation based system, you can see it helps in identifying bad strategy. What we do, we take track parameters at every 25 centimeter by TRC. You can see it at every 25 centimeter. Means in a kilometer you will get about 4,000 parameters for a single 4,000 data for a single parameter. Like if I say alignment of left rail, that data will be 4,000 numbers in 1 kilometer. Alignment of right rail, 4,000. So in such a way, we get the number of data for each defect. Now, for the purpose of evaluation, what we do, we have divided our entire track in different patches of 200 meters. Each kilometer of the track is divided in patches of 200 meter of track. And this machine, what it does, it takes in 200 meters, how many parameters? 800 parameters. It evaluates or it measures all 800 parameters and then calculates the standard deviation amongst these data. As you can appreciate, what does standard deviation, जो नाम उससे क्या पता चलता है कि what is the deviation, what you call difference from generally mean value, so that it gives. So it gives basically non-uniformity existing in the track within this 200 meters as compared to mean value. So this parameter does not gives you absolute value. This I wanted to explain you. This does not give absolute value. This gives the level of deviation from a mean value. ठीक है? Each kilometer is divided into 200 meters block, and for each 200 meter we get a standard deviation value of each defect. If a kilometer of track is more than 1,000 meters, then it may contain six blocks also. But normally it will be 200 meters, 5 blocks. अगर किलोमीटर एक से छोटा है तो लास्ट ब्लॉक विल बी लेसर देन 200 मीटर, और किलोमीटर अगर 1,000 मीटर से बड़ा आ गया देन इन दैट केस द लास्ट ब्लॉक विल बी 6th ब्लॉक. ठीक है, कई बार होता है फील्ड में ड्यू टू मेजरमेंट एरर यू विल फाइंड दैट किलोमीटर इज ऑफ 1040 मीटर, 1100 मीटर और 950 मीटर, इस तरह के किलोमीटर्स होते हैं. तो फॉर दिस आई हैव एक्सप्लेन्ड यू. नाउ व्हाट इट डज, it calculates standard deviation. So it doesn't identify actual defect of any parameter at any fixed location. It gives you indication that this 200 meter patch has got some defect, and it is indicating non-uniformity in say unevenness. So you need to take up this issue and then accordingly make जो आपको input देना है आप दीजिए. So it identifies bad stretch and it is useful in deciding machine maintenance. How do we calculate standard deviation? This is mathematical formula. You can see mu is the mean value. So if I say आगे एक example भी है उसमें आपको दिखा देंगे. ठीक है, mu is mean value of the data set. X is individual value of each and every parameter, 800 values आ गए, and then we calculate in this way standard deviation. You can see through this example, we have 20 stations or 20 data for gauge. Say this is the value. Gauge absolute value. These are the values 0, 5, 3, -3, 0, 3, -2. इस तरह के values आए. Now we can see what is the average value. Average is plus 0.5. This is our average defect, which was mu. Formula में mu was 0.45 हो गया. Now comes standard deviation. Standard deviation के लिए what we do, we calculate x is this individual data, x1 minus mu whole square, x2 minus mu whole square. Then we add all those values, we get this, and then we divide by total number of data set. जो total data था उससे divide कर देते हैं and we get this value. So this is standard deviation. So now you can appreciate that average value was 0.45, but standard deviation is 2.35. This is with one data set where maximum value of gauge was +5 and minimum value of gauge was -3. Now, say one of the location or two of the location defect has increased. At all other places everything is okay. Say this was 0 and this was 0. This has changed. Here now we observe that the defect is plus 15 in place of 0, and here at 9th station it is minus 15. Now you can appreciate one is plus 15, one is minus 15, means average is not going to change, average is again 0.45. But by data set itself you can appreciate that deviation has increased, deviation of data from mean has increased. यहाँ पे बहुत ज्यादा हो गया और यहाँ पे भी बहुत ज्यादा हो गया, तो in turn it will affect your standard deviation. So as non-uniformity increases, standard deviation increases. As non-uniformity decreases, standard deviation decreases. So with this we can conclude that if we have higher standard deviation value for a particular stage, that means what? Track is non-uniform or less uniform. If we have higher value of standard deviation of say alignment defect for a particular 200 meter stretch, what does that indicate? Does it indicate uniformity or non-uniformity?
Non-uniformity.
Non-uniformity, and if we are maintaining a track which is non-uniform in nature, then what it is going to cause to us? What is the end result? अगर ट्रैक में नॉन यूनिफॉर्मिटी ज्यादा है तो क्या होगा? बताइए.
Poor riding. And
it will be subject to
alignment will be wrong, sir.
Alignment तो आपका डिफेक्ट था, अलाइनमेंट आउट है, अनइवननेस आउट है, वो तो आपका डिफेक्ट है. उस डिफेक्ट की वजह से रिजल्ट आ गया कि स्टैंडर्ड डेविएशन हाई है. बट एंड रिजल्ट इज द व्हीकल विल बी सब्जेक्टेड टू एक्सेसिव एक्सेलरेशंस एंड अकॉर्डिंगली पैसेंजर सिटिंग इन द ट्रेन विल फील मोर डिस्कम्फर्ट, है ना. तो नॉन यूनिफॉर्म ट्रैक शुड नॉट बी देयर. जितना ज्यादा नॉन यूनिफॉर्मिटी बढ़ेगी उतना ज्यादा ट्रैक डिफेक्टिव होता जाएगा. मान लो कोई एक सेक्शन आपको मिलता है जहां पे हर जगह गेज +5 है, एवरीवेयर, एंड ट्रेन इज मूविंग थ्रू दिस, इट विल नॉट बी सब्जेक्टेड टू एक्सेसिव एक्सेलरेशंस. +5 की वजह से अनसेफ कंडीशन तो होगा, व्हीकल कैन डिरेल, डिरेलमेंट फोर्सेज विल इंक्रीज, बट डिस्कम्फर्ट लेवल बहुत ज्यादा नहीं बढ़ेगा. वेयर if you are getting +15 here, -5 here, +3 here, -8 here, then in such cases comfort will decrease certainly. इस केस में कंफर्ट कम डिक्रीज होगा. तो यूनिफॉर्मिटी इन डिफेक्ट्स है, यूनिफॉर्मिटी इन ट्रैक डिफेक्ट्स डायरेक्टली अफेक्ट योर राइडिंग कंफर्ट. स्टैंडर्ड डेविएशन पे थोड़ा एक और देख लीजिए, इसके बाद फिर we will move ahead. What does standard deviation mean actually? This was earlier table which we have seen. It has been plotted, and this is the value. This is the mean value. And what was our mean value? 0.45. So as per standard Bell curve, any data set, any normal data set, आप किसी भी पैरामीटर कर ले लो, statistically it has been established that normally within one sigma, within one standard deviation, 2.35 जो है 2.35 स्टैंडर्ड डेविएशन है ना, विद इन 1 सिग्मा 68% ऑफ ट्रैक डेटा विल और एनी डेटा विल रिमेन एज पर स्टैंडर्ड कर्व्स ऑफ स्टैंडर्ड डेविएशन कर्व. विद इन 2 सिग्मा, व्हाट विल बी 2 सिग्मा? 4.70. 2 टाइम्स स्टैंडर्ड डेविएशन मींस 2 into 2.3, 4.70. So from 0.45 to 4.70, 0.45 to 4.70, if you say on minus side, it will become say 4.25 minus, and here it will become plus 5.15. So you will get about 95% of your data, means 95% of 20 means I think 19 data. 19 data you will get generally within these tolerances. And if you go to 3 sigma, means 3.05, 2 into 2.35, that becomes 7.05. So within 7.05 deviation, you will get 99.7% data. This is established mathematical standard deviation curve, and this clearly says that if we are allowing any peak defect within the 3 sigma, it is likely that all data will remain within this. So with this concept, what has been done while we are कोई माइक ऑन रहेगा, जरा ऑफ कर लें काइंडली. हेलो दीपक, जरा माइक बंद कर दीजिए. So it has been established that whatever standard deviation, whatever average value is there, if you allow peak within 3 sigma, you will get almost every data, 997 data out of 1000 data. So it is mathematically established. Accordingly, when we will see tolerances, we will see that the peak tolerances are 3 times SD tolerances. जो टॉलरेंस डिफाइंड किया गया, फर्स्ट वी फाउंड आउट स्टैंडर्ड डेविएशन टॉलरेंसेज एज पर आवर स्टैटिस्टिकल एनालिसिस and regression analysis, and then we multiplied it by 3. This we will see later on. This was just to explain you that what is the relevance of 3 sigma in case of standard deviation or statistical analysis. 99.7% data is supposed to remain within 3 sigma of mean value. यहाँ इस केस में 0.45 अगर है, 0.45 minus 7.05 means it minus 6.42 plus 7.50. Within this 997 data out of 1000 will remain. This is statistical analysis, and you can appreciate now कि जब sigma की value कम है, when sigma is lesser, what will happen? And when sigma is more, what will happen? सिग्मा कम है मीन्स यूनिफॉर्मिटी ज्यादा है ट्रैक में, डेविएशंस आर लेस, एंड सिग्मा ज्यादा है मीन्स डेविएशन इज हाई. सो वी डोंट वांट दिस वेयर आवर ट्रैक पैरामीटर्स आर स्कैटर्ड इन सच ए लॉन्ग रेंज. इतने लॉन्ग रेंज में नहीं हो. वी वांट दैट दिस शुड बी एज लो एज पॉसिबल. ओके, स्टैंडर्ड डेविएशन क्लियर हो गया? मतलब ब्रीफ में है, मैथ्स का क्लास तो है नहीं, मैथ्स में आपको ज्यादा डिटेल में बताया जाएगा. अगर किसी को पढ़ना हो तो स्टैटिस्टिक में स्टैंडर्ड डेविएशन का डिस्कशन है, तो यू कैन रेफर टू दैट. चले आगे.
Yes, sir.
Yes.
So what are the benefits of standard deviation peak we have discussed? Just reiterate now. Standard deviation measurement, based measurement takes into account magnitude of each and every data vehicle, right? As we have discussed, we will get about 4000 data for each defect per kilometer, or 800 data per 200 meter for each defect. And standard deviation जो computer analysis करेगा, each and every data will be evaluated. While in peak based measurement, it will measure only the values which are beyond threshold values. Say I say my gauge should be -3 to +3 for a particular classification. So whatever value is coming in between, this will not be calculated. Only whatever are in this range or this range will be calculated. So we don't actually know what is the condition, overall condition of track, parameter or locations where track is within this tolerance. We are not aware about that. Whereas in standard deviation, we take cognizance of each and every defect or each and every parameter जो भी record हो रहा है. It facilitates isolated attention, and hence we cannot deploy machines on long stage based on this measurement, peak based measurement. SD value indicates more variation and less uniform track profile. Less value of SD indicates less variation and more uniform track profile, and this helps in deciding machine maintenance. Uniform track profile results in better riding comfort. This better riding quality. This all we have discussed. Now we will see what are track tolerances, why we have let down. As we have discussed, we cannot keep ideal conditions for our track. We cannot maintain our track at -3 gauge, 0 cross level, 0 twist, alignment defect 0, or unevenness defect 0. It is not possible practically. So we need some limit within which we can maintain it. For monitoring of track, to appreciate and control quality, all these things we have discussed, है ना? So what are various tolerances laid? When we measure track as per mechanical methods or as per manual methods, what are various tolerances with which we need to compare our measurements? For that purpose, these are the tolerances. Number 1, tolerances under loaded condition. Tolerances under loaded condition for comparing track defects recorded mechanically. ठीक है, इसके लिए loaded condition के tolerances दिए हुए हैं. This can be on standard deviation based method, which identified bad stretches and useful in machine maintenance or spot attentions. Just a minute. It also measures peak based It also gives limit for comparing peak based measurement, and the tolerances in peak based measurement is generally 3 times standard deviation based. We have discussed why, because 99.7% data falls within. It is useful in case of isolated and localized defects attention. We cannot use the analysis with respect to this peak based for deploying our machine on long stretches. Okay. Then tolerances are also laid for comparing the measurements which are taken manually or under floated condition. It helps in recording parameters at various locations during inspection, and it gives in turn isolated defects only. Then tolerances are also laid for judging the quality or output of machine maintenance.
ये IRS T12 का नया वर्जन इशू होना था ना, या हो गया था?
इसमें R263 हुआ है।
सर आप अपना माइक बंद कर लीजिए यादव साहब।
वैसे कहाँ मिलेगा डॉक्यूमेंट को?
यादव सर माइक बंद कर दीजिए प्लीज।
स्लाइड में डाल दिया ना, क्या चेंज किया उसने कंपोजिशन में?
इस स्लाइड में एटलीस्ट
दीपक
सर कर दिया, माइक बंद कर दिया सर।
ठीक। सो मशीन मेंटेनेंस के लिए to judge the output or quality of output of machine, tolerances are laid in machine maintenance track machine manual. What are those tolerances? We can see for loaded condition means mechanical measurement जब हम करेंगे by TRC or OMS, then in those cases we should compare our track parameters with these tolerances. 4 types of tolerances are there. New track tolerances for a track which has been newly laid or newly renewed. ट्रैक रिन्यूअल के बाद भी चेक करना है और ट्रैक नया लेके आया तब भी चेक करना है. देन प्लान मशीन मेंटेनेंस लिमिट्स, नीड बेस्ड मेंटेनेंस लिमिट एंड अर्जेंट मेंटेनेंस लिमिट. This has been incorporated through ACS 149 and 50, and now this is part of new IRPW in Chapter 5. Prior to that, we were having 2 types of tolerances under loaded conditions. One was priority 2 and another was priority 1. Priority 1 was comparable to this UML now, and priority 2 was compared to PML. ये दोनों नए आ गए. New track tolerances and need based maintenance have come new. These two were existing prior to since 2007, but these were introduced new in the year 2019. You can see new track tolerance and need based maintenance limit. Then tolerances under floating condition are of 3 types. These 3 were existing, but this slowdown tolerance was not available earlier. This has been, the instructions were there, but it was not part of manual. In the year 2019, this has been made part of manual, where we have fixed that at places where we cannot increase the speed in the yards or at work site, what tolerance or what track parameters can be allowed. And then third tolerance is machine maintenance tolerance, that is available in the machine manual. We can also call it damping tolerance. When we measure the tolerances for the purpose of TRC recording, when we measure the track parameter as per TRC, so for comparison, we keep these records or we evaluate these records, unevenness, alignment, twist on these chords. Chord length for measurement in case of TRC are the short chord 9 meter, 9 meter and 3 meter for unevenness, alignment and twist respectively, and long chord 18 meter, 15 meter and 15 meter for unevenness, alignment and twist respectively. Okay, so these 3 chord lengths are useful in case of short chord. 3 means 2, one for alignment, one for alignment and unevenness both, and 1 for twist. And here also 2, 1 for unevenness and 1 for alignment and twist both. So 9 meter, 9 meter, 3 meter, and then 18 meter, 15 meter, and 15 meter. This short chord is useful or relevant for good stock, and long chord is useful for coaching stock. It is dependent upon the what you call wavelength of that coaching stocks. तो coaching stocks का wavelength ज़्यादा होता है. तो माइक ऑन हो गया क्या दिव्य किसी का? So for good stock, this short chord measurement or short chord tolerances are relevant, and long chord are relevant for coaching stock. Our twist for 15 meter is not relevant for field people, as we know that. Why this twist is not relevant for field people? Can anybody say? What is the length of bogie? Normally in our case, bogie की क्या लंबाई होती है? Bogie of rolling stock. Normally it will be between 2.5 to 4.5 meter. 4.4 मीटर के आसपास होता है लोगों के लिए, और इधर जो 2.53 मीटर होता है, that is for coaching or good stock. In fact, for Kasav it is 2 meter also, तो 2 to 3 meter के रेंज में होता है. So this we can see that twist on the base of 3 meter is sufficient enough for a bogie to negotiate. उसके बाद वाला 15 meter वाला is not useful for negotiation of twist by normal rolling stock which is under movement, but this data is useful for RDSO people for evaluating any new stock. So that's why no tolerance have been fixed for this. इसके लिए कोई tolerance limit नहीं explain की गई है, नहीं दिया गया PV manual में. This is only for research purpose, not for field people. Whereas we will get tolerance for all these five what you call 5 defects, 3 short chord defects and 2 long chord defects. इसके लिए tolerance written down है. Prior to 2014, this was modified in the year 2014. Prior to that, these were the track, what you call chord lengths, unevenness 3.6 meter and 7.2 meter, and twist 3.6 meter in case of short chord, and long chord के लिए 9.6, 9.6, 4.8. This has been revised. I told you why. These are the reasons: improved suspension system in existing and new rolling stock, increase in speed potential, and chord used in track machine also matches with these lengths. So accordingly, these tolerances have been modified considering these things. I am not going into the details of design of chord length changes. That may be covered in the जो आपका TRC का class है उसमें वो cover होगा. We are not going to cover that. But where we measure, what chord length we measure, and why do we measure, those things I have explained to you. Floating condition के लिए as of now, these are the chord lengths to be followed for alignment: 10 meter, 20 meter and 7.2 meter, depending upon what kind of tolerance, curve में ले रहे हैं, straight में ले रहे हैं, machine के लिए ले रहे हैं, उसके लिए अलग अलग provisions है. Unevenness 3.6 and twist is 2.4, 3 and 3.6. 3.6 I think now it has been changed to 3 meter. So tolerances under loaded condition, if anybody wants to understand in full detail how it has been arrived, they can refer to this report. I have taken extract just to explain you, but if anybody wants to read it into depth, they can download it from RDSO website and then read it. It's hardly 20-page document, but it clears every concept about TRC tolerance limits, how it has been fixed. Okay. This you can see. When we measure our track parameters, this is the format in which we measure it. We measure SD value for unevenness left, unevenness right. You can see here. Yes. Unevenness left, right, then alignment left, right, on short chord, then on long chord similar values we measure. Then what are peaks? These parameters we measure, and accordingly these measurements are compared with the tolerances given. This is just for your information that we get TRC result in this format as per new TRC. This will be discussed in greater detail in your TRC class, which will be taken later on. So we'll see जो this report की हमने बात की उसमें how we arrived at certain tolerance limit. So the logic or the reasoning behind deciding these tolerances are economy, maintainability, and duly ensuring safety as well as comfort. The principle of touching the track only when required and where required. We should not give extra input to ensure objective decision making and plan maintenance interventions accordingly. Means we need not touch the track where it is not required. That is the basic principle. Duly ensuring that safety and comfort is not compromised. So that is the basic motto of deciding these tolerances, and these tolerances have been decided based on a statistical analysis of about 20,000 kilometer data. These tolerances, what I call new track limit, land maintenance limit, or need based maintenance limit. These tolerances have been decided based on 20,000 kilometer of track parameters data or TRC data. उसका पूरा statistical analysis किया गया, and then this has been evaluated. Out of those 20,000 kilometer, you can see out of this 20,000 kilometer, we have evaluated 25 sections which were of a speed band less than 100 kmph, 36 sections within the speed of 100 and 110, 32 sections within the speed of 110 and 130, and 4 sections of 130 to 160. Where after deciding the value based on a statistical analysis of this 23,000 kilometer TRC result, it was further scientifically correlated by regression analysis by comparing the track defects of these sections with the ride index observed in the same run. So what are the defects which can correspond to what ride index that were correlated, and then established that the decision taken through a statistical analysis is okay or not. ठीक है ना, थोड़ा बहुत मॉडिफिकेशन भी किया गया स्टैटिस्टिकल एनालिसिस पे जो डेटा है उस पे बेस्ड ऑन रिग्रेशन एनालिसिस के समय में थोड़ा बहुत चेंज भी किया गया, बट जनरली इट वाज ऑब्जर्व दैट जो बेल कर्व का कांसेप्ट था दैट वाज प्रिवेलिंग हियर, और उसके हिसाब से ठीक ही आ रहा। ठीक है, जिनको देखना हो दे कैन रेफर टू द रिपोर्ट व्हिच आई हैव मेंशन्ड, उसमें पूरा डिटेल में एक्सप्लेन किया हुआ है। नाउ फॉर deciding new track tolerances, what has been done, you can see. First of all, the entire defects were plotted on statistically, and a cumulative frequency diagram was prepared. We'll see. First of all, let's see it. So let's see, this is CFD of unevenness. Means what percentage of track having what defect, and table statistics में table बना के we can plot CFD. So this CFD was plotted for this defect, and then corresponding to 10%, what is the defect value? This set the limit of new track tolerances. 70% के corresponding जो defect आया, this was used for deciding planned maintenance limit tolerances, and 95% के corresponding जो defects आए, that was used for NBML. So accordingly for each section such parameters were calculated. Like मैंने कहा आपको less than 100 kmph में 25 sections were analyzed. So for those 25 sections, for each section, each of the parameter were plotted. ठीक है ना, and after plotting 10% CFD के corresponding value, 70% CFD के corresponding value, and 95% CFD के corresponding values को ले लिया गया हर सेक्शन के लिए. तो से सेक्शन A के लिए some value came 1, B के लिए 2, इस तरह से 25 सेक्शंस के कुछ वैल्यू आ गए. अगेन दीज वैल्यूज वेर प्लॉटेड स्टैटिस्टिकली, फिर इसकी प्लॉटिंग की गई, स्टैटिस्टिकल एनालिसिस किया गया, एंड उसमें टू अवॉइड सर्टेन व्हाट यू कॉल एरनस डेटा और एक्सेसिवली डेविएटेड डेटा, उसको हटा दिया गया टू अवॉइड एनी एरर इन मेजरमेंट और टू अवॉइड एनी एक्सीडेंटल डेटा, एंड देन वी evaluated various tolerances. So this is, you can see, this is one sample graph or sample statistical CFD diagram for unevenness. This is for alignment. This is for unevenness on long chord. This was on short chord 9 meter. This is on long chord 18 meter. And similarly, this is alignment on short chord and alignment on long chord. तो इस तरह से एनालिसिस करके अनइवननेस और अलाइनमेंट का स्टैटिस्टिकल एनालिसिस किया गया. एंड फॉर न्यू ट्रैक लिमिट यू कैन सी SD value corresponding to 10% defect size for each sections were taken, and then for each section 10% defect size जो आया उसका again CFD draw किया गया, and then 70% line has been taken to get the track within 30%. So with this analysis we can conclude that roughly we can conclude, of course, this statement is not perfect statement, but roughly we can say that only 3% of Indian railway sample track means जो हमने 25 sections लिए या 32 sections लिए या 4 sections लिए 160 kmph के, तो इन sample tracks में only 3% of the tracks were track defects within these limits. So we have set our new track tolerances to such a standard that we can generally say that Indian Railway में 3% से ज़्यादा track इस tolerance limit में maintain किया हुआ नहीं है. If we extrapolate the data, otherwise sample size में 3% was the limit. Only 3% of Indian rail track was within this limit. So that was based for new track limit. For planned maintenance limit, as I told you, 70% defect size was there. And then those 70% defect size for each section was again plotted on CFD, and then 5% data was left to exclude extreme or erroneous data. So this gave us logic, or this gave us base to lay down the tolerance of planned maintenance limit. And now roughly we can say that 66.5% of Indian railway track were with such defects. जो लिमिट हमने सेट किया से हमने PML में, if I have said a tolerance defect of 2 mm, so we can say that this 2 mm defect is prevailing in 66.5% of the Indian railways. Then need based के लिए accordingly this 70% become 95%, and roughly we can say that more than 90% of Indian railway track were with these defects. ठीक है? So this was basic how NTL, PML and NBML has been arrived. Internationally, if you see, these are the provisions of European standard. They maintain an alert limit, intervention limit and intermediate action limit. If we compare alert limit with our, then we can say PML, intervention limit means NBML, and immediate action limit means UML. Equivalent. And similarly, UIC is this QN1, QN2, QN3, these are all similar. Now we will see these tolerances one by one in detail. What are those tolerances? Number one, we will see new track tolerance. पहले ये ACS 14950 से आया था, but now this is part of new IRPW, which is available on Edison website. In the chapter 5, all tolerances have been included. We'll see. This we have discussed. SD value 10% के corresponding plot करके, and then again 70% का जो value आया था उसको ले लिया गया था. This will be compared with track parameter which have been measured 3 months after speed is raised to normal. So we should not compare the track measurements immediately when section is being taken or has been taken. We have to wait for 3 months and then we have to take the measurement, and those measurements will be compared. This parameter sets a track output quality which is of best quality, and this acts as a reference for quality control of track renewal work or track laying works or new track works. किस तरह की quality का work हुआ है, we can judge it. Highest level of geometrical parameter of track that can be achieved on a new or relayed track with new material. If everything has been kept new in the renewal or what you call laying of new line or doubling, then what best quality can be achieved? This is indicated by new track tolerance limits. And we can appreciate that better the lay down, or while laying down, if quality of the track laying is better, in long run, we are going to need lesser maintenance input or better riding comfort or better safety. There is nothing to explain in that. This has been laid for unevenness defect, alignment defect, both SD based and peak based. ठीक है ना? इसमें गेज और ट्विस्ट का लोडेड कंडीशन में नहीं दिया गया. Loaded condition में only unevenness and alignment has to be examined, and the data or the tolerance is both SD based and peak based for new track limit. These are in 2 speed bands. First is less than 100 kmph and another is 100 to 160 kmph. These are the values we can see. If the speed is less than 100 kmph, SD based value for unevenness on long or short chord is 2 mm. If any block of any 200 meter block during TRC run gives more than 2 mm, then that will be considered as defective or what you call inferior quality as compared to new track tolerances. Peak based you can see multiplied by 3, 6 mm. So if peak value of gauge or peak value of unevenness or alignment is more than 6 mm, then we will say it inferior. For higher speed band, we can appreciate that speed for higher speed band uniformity should be more. Is it okay? Uniformity ज़्यादा होनी चाहिए, speed band बढ़ गया तो चलेगा ना? Okay or not? Participants?
Okay, sir. Okay.
So you can see it as you increase in the speed band, this range reduces, and similarly 1.4 into 3, 4 mm. So in this way, new track tolerance for unevenness have been fixed. Here we find no data, unevenness 2. What is the region? इसका region क्या है? There is no unevenness data. What is the region?
Speedless.
बताइए.
Goods के लिए.
Long chord is not relevant for good stock, and UN2 means long chord. तो long chord relevant नहीं है good stock के लिए, and good stock passengers generally don't run at speed less than 100 kmph. Less than 100 kmph पे goods चलता है, so this becomes irrelevant for the purpose of judging the track quality. So accordingly, we don't find long chord unevenness data, but in high speed band in which passenger trains move, these data are given. So as chord length increases, the tolerance limit should increase or decrease. Chord length बढ़ने से हमारा ट्रैक पैरामीटर का वैल्यू बढ़ेगा या घटेगा? If we are increasing the chord length, we will get higher value of track parameter or lesser value of track parameter.
Higher value.
Jay?
Higher value.
Higher value. Okay. So since we will get higher value, we need higher tolerance. Okay. So you can see it will increase in this direction. It will increase when the speed band increases. It will decrease when the speed band decreases. And peak based will be generally 3 times of SD based. We cannot remember all those values, but we should have general understanding that how this has been arrived and what is the general trend according to speed, according to chord length, what is the relation between SD and peak based, like that. So similarly, you can find out alignment defect tolerance 1.4 mm and 4 mm, and here for higher speed band 1.1 and 3 mm, and then when chord length increases, this tolerance increases again. Here we will find no tolerance. Why? Because this is not, long chord is not relevant for good stock which runs at speed less than 100 kmph. Okay. ठीक है, new track tolerance. Okay.
Okay.
So now we will see planned maintenance limits which are mentioned in para 521A of higher PWM, and this is for guidance for planned maintenance of complete block section, mechanical maintenance or machine maintenance के लिए, guidance के लिए. It will help in planning the maintenance input. When the track parameters are crossing these limits, it does not mean that we have to immediately apply maintenance input, but we need to plan it. इसके लिए कुछ condition दिया हुआ है, कब करना है, क्या करना है, that you will see. Again, PML, since it is not going to affect safety of our track, no tolerance for gauge and twist has been given. Only unevenness and alignment defect has been given, and that too only SD value. Peak value नहीं दिया हुआ है, सिर्फ SD limit दिया है, because riding comfort is affected by SD value only, and this limit is not going to help you in giving isolated attention. This limit has been let down so that machine can be deputed over a longer stretch. So we need not do isolated maintenance based on these limits. That's why no peak value, and there is no safety issue concerned when track parameters are crossing these limits. So no limit for gauge and twist has been given. So this is the rationale behind it. You will find only standard deviation based unevenness and alignment limits under planned maintenance tolerance. So it is for 4 speed bands. We will see it. 100 less than 100, 100 to 110, 110 to 113, 100 to 116. So unevenness on short chord we can see 5 mm. जबकि न्यू लाइन के केस में क्या, न्यू ट्रैक के केस में it was 2 mm. So you can see, you can appreciate it also that new track का better रहेगा. Once we have operated, we have started running trains on it, track will deteriorate and certainly our parameters, track parameters will deteriorate. So we need higher tolerances to compare. So you can see it, that new which was 2 mm, new tolerance was 2 mm, planned it reached 5 mm. It will further increase case of NVM. 100 to as speed increases, it decreases, and in the highest speed band it is 2.9. Where there in that case, in new track के case में it was 1.4 mm. Long chord again less than 100, not relevant, not so not given, no limit given. Beyond 100 you can see the value. As the chord length increases, this will increase. Okay. Alignment also similarly, this value was 1.4 in case of new track limit. Now this is 3.3 and it decreases in this direction and becomes finally 1.9, which was I think in that case 1.1. And as long chord length increases, this tolerance increases. Long chord less than 100 kmph not relevant. Okay, gauge twist का कोई tolerance limit नहीं दिया है. Reason क्या है? These are not affecting riding quality, so we have not given. Peak based, why it has not been given? Why no peak based tolerance has been given in this case? PML के case में? What is the reason? We have not been given with the tolerance for peak based measurement in case of PML. Reason क्या है उसका? I have explained. अजय कुमार जी, एएन मुगल सराय, आप हैं?
यस सर.
बताइए. Why peak based limit has not been given for PML in case of unevenness and alignment? What is the reason?
Sir, there is no need because there is no safety involved. We have to do maintenance.
आपका जवाब पूरा ठीक नहीं है, दोबारा सोच के बोलिए.
Sir, peak-based defects are localized defects which does not require use of track machines for their geometry correction. And plant maintenance limit is limit which require improvement of the riding quality by the use of track machines. So basically, it is for planning improving overall running quality of a block section, not a localized defect.
And number 2, you are right, it is not for judging the localized effects of the track, it is for deciding overall long stretches of machine maintenance, where it is required or not. And peak based, if you see, it is required for isolated attention. So PML के basis पे we don't decide that where we need to, ऐसा नहीं कि machine इसके basis पे we cannot depute, we can depute it, but we will depute on longer stretches, whereas peak based is useful for isolated attention, maybe by machine, maybe manually, that is irrelevant. But we have, when we need maintenance of some spots, some fixed stretches, small stretches, then only then this PML is not relevant, and that's why no peak based value has been given for PML limit. Clear हुआ, Mr. Ajay Kumar?
Yes, sir.
ठीक है?
Yes, sir.
So based on track measurement recorded by TRC and compared with PML, how track maintenance input will be planned, how track maintenance planning will be done. So it gives that the blocks in para 523.3 it says that the blocks requiring planned maintenance on the basis of laid down SD based PML shall be identified for block section and for yard separately. Block section का मतलब क्या है? It has been defined. Block section, say this is your station and this is your and similarly this side. So it says block section means this side first SEJ and this side last SEJ. Between this distance, it will be considered as block section. So block section will be analyzed separately, and then from this last SEJ to this last SEJ. Yard के बाहर जो you can say first SEJ or last SEJ, whatever. If you are coming from center of yard, we will call it last SEJ of yard, and in this side last SEJ of yard. This will be treated as yard. So these two portions will be evaluated separately for the purpose of comparison with PML. So the block section will be compared with ब्लॉक सेक्शन का अलग कंपैरिजन करेंगे और यार्ड का अलग कंपैरिजन करेंगे, एंड सेज दैट इन केस रिकॉर्डेड स्टैंडर्ड डेविएशन डिफेक्ट इन दिस ब्लॉक सेक्शन इज मोर देन 40% स्ट्रेचेज, पीएमएल के लिमिट को मोर देन, सो इस ब्लॉक सेक्शन में से ब्लॉक सेक्शन की लंबाई से 9 किलोमीटर, इन 9 किलोमीटर वी विल जनरली गेट 45 what you called TRC block, 45 TRC blocks. So now we have to see that the stretches or the TRC blocks where PML limit has exceeded, whether it is more than 0.4 into 45 or not. That we have to see. अगर इससे ज्यादा हो गया, we have to plan maintenance. We did not give immediate maintenance input. तुरंत नहीं देना है. But if it is increasing, then we have to plan for maintenance, maybe in 1 year, maybe in 6 months, maybe in 2 months, depending upon traffic density, depending upon track condition, everything will matter. But we have to start planning for track maintenance. Whereas we will compare yard separately and we will see that if 50% से ज्यादा अगर PML लिमिट को क्रॉस कर रहा है, 50% से ज्यादा TRC ब्लॉक्स में अगर PML लिमिट को क्रॉस कर रहा है, then we will plan for maintenance. Okay, ठीक है? Now we will see the third maintenance for loaded condition, that is need-based maintenance limit. And as the name suggests, need-based means as and when need has erosion, we have to maintain it. Means we may have to give isolated attention, we may have to give attention in stretches, anything can happen. So it acts as a reference for need-based maintenance of blocks of 200-meter track for applying timely correction before the defect size grows to the level of next tolerance limit, that is UML. If we reach UML, that will require traffic slowdown. But what will be standard time for applying correction once our track parameter has crossed the limit of NBML? That will depend on local conditions, and the concerned sectional PWI, sectional AEN, sectional senior DN can decide it in better way. Of course, it will depend. You can appreciate on many factors. What are the loading conditions? What is the speed of the track? Speed on the track? What is general track deteriorating rate in those areas? What is the condition of track fittings, track structure? Everything will affect the time required to attain that localized defect. So that has to be decided section wise, but normally 15-20 दिन में कर ही देना चाहिए. Because if you don't do and something happens, caution order applies, then you have to reply also. So we can see, since it is need-based terms itself, that it has become urgent. We have to do something. And when we have to do something means it may be unsafe also, it may be poor ride, very poor ride comfort also. दोनों factor हो सकता है. Accordingly, you will find that it gives unevenness and alignment defect also and gauge and twist defect also. दोनों के लिए tolerance इन्होंने दिया है. NBML में we get tolerance for unevenness and alignment also and gauge and twist also. Gauge and twist, as we have discussed, what does it affect? Riding comfort or safety? Safety and unevenness and alignment. Generally, riding comfort is more prevalently affected by unevenness and alignment. Since we have to maintain stretch as well as isolated locations, so tolerances have been laid for standard deviation also and peak based also. Gauge and twist के लिए सिर्फ peak based है, because it is not related to uniformity of track or riding comfort, it is related to safety, so only peak based limits have been given. And then again this has been laid for 4 speed bands. What are those limits? We can see 4 speed bands, 100, 110, 130, 160. Unevenness on long chord, short chord. You can see earlier it was 2, then 5, and now NBML is 6.8 mm. And this peak based multiplied by 3, as we have discussed earlier. And then according to speed, these tolerances decreases and this become 4.4 mm. ठीक है ना, 1.4 था, 1.9, 1.4, 1.9 and now it has become 4.4. So this is increasing as per NTL में सबसे कम था, PML में उसके बाद है, NBML में उसके बाद है. क्लास चल रहा था, ठीक है. Then again long chord में unevenness defect not required for this speed band, so not given, and you can find these defects. As the chord length increases, the defect size or the tolerance size increases. Alignment similarly, you can see it. It was 1.4, 1.1, and now it is 4.9 mm for NBML, and it is increasing in this, decreasing in this direction and increasing as per chord length. Again, value of peak based is generally you will find 3 times rounded to nearest round figure. ठीक है. So गेज एंड ट्विस्ट के लिए क्या दिया हुआ है, एवरेज गेज बताया है, आइसोलेटेड गेज का टॉलरेंस दिया और ट्विस्ट का टॉलरेंस दिया है. अगेन 4 स्पीड बैंड हैव बीन गिवन, बट effectively it is not 4 speed band. For gauge it is generally 2 speed band only. We can see up to 130 same tolerance is given, up to 130 kmph same tolerance is given. Now in PV manual we see 4 tables and for each table values have been given, but ultimately if you see these are 2 tolerances, 130 tak -8 to +10 in case of straight track, in case of mild curves -5 to +14, and in case of sharp curves this is -5 to +18. For higher speed band this negative side also, the negative side gauge has been further relaxed little bit, -8 to -6 here. In this case it has been reduced on plus side, so these are values we need not remember, but this side if you increase the speed, tolerance will decrease, and as sharpness increases, range of gauge increases. This we need to understand. Otherwise, values we cannot remember it. Those who can remember certainly can keep in mind. Otherwise, manual में सब कुछ दिया है, but logic should be clear. Okay. Then this was mean gauge, and if mean gauge tolerances से isolated gauge हमेशा ज़्यादा allowed रहेगा. So we can see here this was -8 to +10, but in case of isolated gauge on a straight track this tolerance has been increased to -10 to +12, and as speed increases this value will decrease similarly. For twist also you can see it here. Three limits are given. जी बताइए.
ये सर मेन गेज का क्या है?
क्या?
पर्पज ऑफ मेन गेज
मीन गेज का पर्पस तो वैसे बहुत कुछ ज्यादा नहीं है, बट वो टॉलरेंस दिया. मीन गेज का पर्पस ये है कि ओवरऑल आपको पता चले कि बहुत ज्यादा डेविएशन वेरिएशन बहुत वो मतलब एक वन ऐसा हो सकता है ना कि गेज यूनिफॉर्मली +5 है, यूनिफॉर्म +5 है, और एक में +5 -5 +5 -5 ऐसा करके जा रहा है, तो यू विल गेट मीन गेज 0, whereas in this case you will get +5 ही यूनिफॉर्म गेज मिलेगा. तो दिस विल गिव यू जनरल गाइडेंस कि मेरा गेज जो है इफ इट इज increasing on some positive side or some negative side, so that will indicate that generally gauge is widened in this area. It gives you general understanding of that gauge. Otherwise direct impact तो नहीं है, direct impact isolated gauge का ही, ठीक है ना. Then twist के लिए 3 स्पीड बैंड दिए गए हैं, up to 100, then up to 130 and up to 160. 5 mm per millimeter, 4 mm per millimeter and 3.5 mm per millimeter. These are the values. What is to be done in case of NBML limits have been crossed by our track parameters during TRC run? So number 1, we have to immediately plan, or as soon as possible we should try to attend it, so that the defect size does not reaches to UML limit. If it reaches to UML, NBML पे speed restriction नहीं लगाना है. NBML पे we have to give maintenance input as soon as possible. But if we cannot give, if we don't give in time, then what will happen? It may happen that your track defect size increases, and then you have to apply caution order if UML defect limit is reached. So immediate attention has to be given, that we have discussed. And it says that if gap between 2 NBML patches is less than 200 meters, then that gap should also be attended. So along a track, this 10 kilometer block section is there, and at 2 locations you got NBML. If the length in between is less than 200 meters, then this entire patch will be attended. while we are attending the track. And if it is more than 200 meters, then this will be attended separately and this will be attended separately. That is the instruction. In case the NVML falls in turnout area, say this is the location where NVML happened and turnout itna bada hai, turnout yahan se yahan tak hai, then it says that entire turnout to be attended. It's not that only this location will be attended. These are instructions as per this letter, and now this is part of POM manual also. Now the third kind of tolerance in case of loaded condition is urgent maintenance limit. You can see it says that if these limits are exceeded by our track parameters, track measurement, then in such cases we have to reduce the speed. We have to impose the caution order, and that's why it was indicated in NVML that as soon as NVML reached, try to attain the track as soon as possible. Otherwise, we will reach here and then we have to apply caution order. And this is based on acceleration peaks and then gauge twist defects. ठीक है ना? How we will make speed reduction, or what we will reduce our speed to what extent, that will depend upon what is the acceleration peak value on our track. That will decide. We will see how it will be decided. In these limits, peak based tolerances for average gauge, isolated gauge and twist has been given. No unevenness, no alignment, because this is not going to affect riding quality only. Now this is somewhat related to safety. That's why limits are for these things. And as far as safety is concerned, accelerations are very relevant. So limits have been laid for this. And again, it is in 4 speed bands. You can see 4 speed bands are this. Acceleration up to 110 kmph. If acceleration is less than 0.3 g, it's okay. If it is increasing more than 0.3 g, then we have to impose a caution order. 110 to 130 के सेक्शन में अगर 0.25 g से ज्यादा पीक आ रहा है एक्सेलरेशन का, then we have to reduce the speed and we have to come in this range. अगर ये 0.3 g से भी ज्यादा आ गया अगर इस रेंज में, if your speed TRC recording speed is 130 kmph and we get acceleration peak of 0.35 g, then we have to reduce speed less than 100 kmph. What will be value? That is not written, that sectional PWI or agent can decide, but this will not be 100, this will not be in any case between 100 to 110. It will be less than 100 kmph. If TRC is recording at 160 kmph and giving you TRC or OMS or oscillograph car, anything returnable, if it gives you a peak of 0.2 g, more than 0.2 g, up to 0.2 g, it is okay. If it is more than 0.2 g, then either you have to come in this range, or we may have to come in this range, or we may have to come in this range, depending upon value of peak. Say this is 0.24 g. We observed a peak of 0.24 g. Then we will reduce our speed in this range. If our acceleration peak value is say 0.28 g, we will come to this range. If it is less than more than 0.3 g, say 0.35 g, then we have to come in this range, less than 100 km. So this is instruction as per POM manual. You have to reduce the speed and reduce the speed in this logic. Then mean gauge limits are given, जैसे NVML में था उसी तरह का दिया हुआ है same, but उससे value certainly UML का limit will be higher than NVML. यहाँ पे -6 to +10 था if I recall, यहाँ पे -10 to +12 हो गया. Similarly कर्व जैसे जैसे शार्प कर्व होता जाएगा, नेगेटिव साइड में गेज कम होता जाएगा, पॉजिटिव साइड में बढ़ता जाएगा. Isolated defects higher than the defects of mean value, and then twist value 7 mm, 6 mm and 5 mm. This was 3.5 mm in NVML, now this is 5 mm per meter. So these are the limits of UML. Okay. So just a graphical representation of various tolerances. Of course, it is not to scale, it is just for understanding. If you lay a track, you lay to the highest standard, best quality track you lay, you have laid it, the best quality track, we have laid it. Now once operation has started, with time what will happen? These are 4 tolerances actually. In new track, highest quality of new track, then PML के लिए जो quality है वो this level का है. This is not to scale. Again I am repeating, not to scale. Don't, just for your understanding, this has been indicated. And these are NBML tolerances below which we should give maintenance input immediately. If our track quality is below this, we need to plan maintenance input so that our track before reaching NBML gets desired input. And if it is crossing these limits, then we have to restrict caution order, speed restriction. Okay? So we lay our track to the best standard. NTL पे हमने lay किया. track will start deteriorating, then at some point of time it will come below PML. We will take sufficient time and then we will try to give maintenance input as soon as track doesn't reaches, before the track reaches NPML tolerances, and by giving the input again our track standard will improve, track quality will improve. Not up to new track limit certainly, because new track time ke saath the wear and tear will come in the fittings, track materials, bala, sleeper, everything. So we cannot achieve original, but we will try to reach as near as possible. Then again maintenance in deterioration will start. Then we will give maintenance input. In similar cycle this will happen. And NPML के case में हम लोग time भी देते जाएंगे. So this is just for your understanding. We give regular maintenance input to upgrade our track to better quality and try to achieve as near to NTL or PML, above PML as possible. अगर PML के अंदर track को हम नहीं ला पा रहे, then we need some additional input like new material or renewal like that. ठीक है? We have discussed all tolerances which are prevalent as of now in loaded condition. So एक एक करके kindly reply. What is the first tolerance for loaded condition? Anybody? SKS बताइए. SKS पूरा नाम क्या है आपका?
NTL.
पूरा नाम क्या है आपका SKS जी?
सुधीर कुमार सिंह.
सुधीर सिंह जी. First is NTL and what limits that it contains? किसके लिए दिया न्यू ट्रैक लिमिट?
Unevenness alignment.
For how many speed bands?
2 speed bands.
2 speed bands. और SD peak दोनों दिया है या सिर्फ SD दिया है या सिर्फ peak दिया है?
SD peak दिया है.
Yes, right. ठीक. Okay. Then next, anybody else? AN SRE. Next tolerance is
PML, sir.
PML. How many speed bands?
4 speed bands, sir.
And what are the parameters for which it has been given?
Sir, unevenness and alignment, sir.
And only ST based. ठीक है? Gauge twist दोनों में नहीं है. NTL में भी नहीं है, PML में भी नहीं है. But NTL में peak based values are there.
Yes, sir.
Okay. Then third, anybody else? What is third tolerance? Mr. Mangal? Are you there, Mr. Mangal? Mr. Sogra? OP Sogra? और कोई बताना चाहते हैं? संजय त्यागी, सबीन असाफ. Anybody who want to reply? Sir Surendra?
NBML, sir.
NBML. And for what parameters?
It is for all parameters are there, sir.
Okay.
That
And-
is
Okay. All parameters and in 4 speed bands, that's okay. But
Yes, sir.
standard deviation based for unevenness alignment, peak based for
Alignment.
unevenness alignment, and for
And
gauge and twist, average
gauge
gauge,
twisters, peak.
and for twist only peak. Okay.
Yes, yes, sir.
And then last is UML, which is again in 4 speed bands, peak values for lateral and vertical acceleration, peak values for gauge, average gauge, and absolute gauge and twist. So these are all tolerances laid down in IRPWN for loaded conditions. अगर किसी को कोई confusion है, he can ask question. Otherwise, we are moving to floating condition tolerance. ठीक है?
Yes.
चलें आगे?
Okay, sir.
So in floating condition also 4 tolerances have been laid. One is new track, another is existing track, third is realignment. For realignment of track, what is the tolerance? And then slow down tolerances. This has been newly included in IRPW that as I have already explained you. So for new track, it is to be measured 3 months after the speed is raised to normal to judge the quality of work done in case of new laying of new track or renewal of track. And this is mentioned in para 523. It is irrespective of speed band and और फॉर ऑल फ्लोटिंग मेजरमेंट नो एसडी वैल्यू का कंसेप्ट है नहीं, क्योंकि मैनुअल मेजरमेंट में वी डोंट डू स्टैटिस्टिकल एनालिसिस, तो आगे जो भी मिलेगा उसमें कोई एसडी वैल्यू ही रहेगा, ठीक है। सो इट सेज गेज ऑन स्ट्रेट्स इंक्लूडिंग कर्व्स अप टू 5 डिग्री, मतलब 5 डिग्री से फ्लैट कर्व हो या स्ट्रेट हो, in that case gauge of for new tracks should be -5 to +3 mm, and curves sharper than 50 mm this should be +10 mm gauge. Okay, cross level which is to be recorded on every fourth slipper means how many meters? 2.4 meters. So for every 2.4 meter it should be ±3 mm. Alignment on a straight when it is measured with 10 meter chord, this should be ±2 mm. And variation of theoretical versine in case of curve which is to be measured on 20 meter chord should not be more than 5 mm for flatter curve. Here flatter curve means about 3 degree and sharper curve means less than 3 degree. Not exactly 3 degree, radius is 600 meters, so it will not be exactly 3 degree, but for just for your memory I am saying it. Then for realignment of curve, some criteria has been fixed. Again, this has been divided in 4 speed bands. It is mentioned in 524. It says it has divided speed into 4 categories. Number 1 is speed range between 110 to 160. Another is at 110, then 110 to 50, and then below 50. What tolerance or what variation, station to station variation in versine can be allowed before realignment, or if what limit is crossed, we have to think for realignment. So it says that for highest speed band, if station to station versine variation is more than 10 mm, then we need to plan for curve realignment, or 15 mm at 110 kmph, or between 50 to 110 kmph it should be 20 mm. 20 mm से ज्यादा हो गया तब प्लान करना पड़ेगा, और 40 mm से ज्यादा हो गया तब प्लान करना पड़ेगा for speed less than 50 kmph. But this value 10 mm, 15 mm or 20 mm or 40 mm will also be compared with this. What is the average versine of the curve? Say curve has 20 stations, total versine is say 800 mm. Versine of all, joining the versine of all stations we get 800 mm. So per station it is average versine is 40 mm. So again this 40 mm का 20% हम check करेंगे into 20%, that is 8 mm. So now whichever is higher, this 10 mm is higher, we will compare it with 10 mm, or if this value is higher, we will compare it with this value. The stations which are exceeding either this value or 20% of average versine, those will be counted, and after counting what will be done? If the variation are at few locations, we will do local adjustment. If variation is at more than 20% stations, so here we saw 20 stations, so variation crossing these limits, maybe this, maybe this, maybe this, maybe this. In any criteria, as per speed band, maybe in first this, second this, third this, fourth this. If this criteria is being breached or these limits are being exceeded at 20% of these 20 stations, means 4 stations, then we will plan for realignment, and that realignment we have to do within a month. This is as per 524. Okay.
हेलो,
हाँ बताइए।
यस सर, एक बार फिर एक्सप्लेन करेंगे 20% वाला क्राइटेरिया।
से आपका कोई कर्व है, उसका स्पीड रेंज है 110 to 160. जिस ट्रैक का आप कर्व मेजरमेंट कर रहे हो उसका स्पीड बैंड है 110 to 160. उसमें एक कर्व है जिसमें टोटल से 50 स्टेशन आर देयर, ठीक है। तो -3 से शुरू होगा और बढ़ते बढ़ते फिर ये 1 2 3 50 तक जाएगा, फिर +3 तक भी लेते हैं, ठीक है। नाउ वर्साइन भी मेजर्ड एट ईच लोकेशन, कुछ तो आइडियल वर्साइन होगा, ठीक है ना।
यस यस,
आइडियल वर्साइन कुछ हो गया, मान लो 30 mm वर्साइन था आइडियल, ठीक है। एवरीवेयर इट शुड हैव बीन 30, ट्रांजिशन में थोड़ा कम रहेगा। तो नंबर 1 वी विल मेजर ऑल द सम ऑफ ऑल द वर्साइंस, उसको हम निकाल लेंगे। तो सम बिकेम 30 into 50 stations, it became 1500 mm, sum of all वर्साइन, नंबर 1। नंबर 2, अब एक्चुअल मेजरमेंट करोगे अब वर्साइंस का, तो से हियर इट वाज 24, हियर इट वाज 44, हियर इट वाज 68, हियर इट वाज 22, इस तरह के कुछ वैल्यूज आए। तो आप सबसे पहले देखोगे स्टेशन टू स्टेशन वर्साइन डिफरेंस, हाउ मच दिस इज 24 to 44 20 mm, this is 44 to 68 24 mm, here it is 44 mm, whatever value comes, it is just ऐसे ही वैल्यू लिख रहा हूं तो थोड़ा एक्सेप्शनल वैल्यू दिख रहा है, जरूरी नहीं कि ऐसा ही आएगा, ठीक है ना। तो ये वैल्यूज आ गए। नाउ वी विल कंपेयर इट विथ नंबर 1 दिस 10 mm लिमिट। हमारा स्पीड बैंड क्या है 110 to 160, दिस इज ओके, and for 110 to 160 the limits are 10 mm. So now this difference I will compare with 10 mm. So this station has crossed, so we will count this station. This station has also crossed, we will count this station also. This station has also crossed, we will cross this station also. Now say this comes say 22 की जगह ये फिर 20 आया, now this difference is only 2 mm, this will not be counted. So here what I found that 3 stations have crossed these limits. Number 1, first limit was this. Second limit क्या था, वर्साइन का 20%, तो 1500 mm का 20% कितना हो गया 300 mm, सॉरी एवरेज वर्साइन का मैंने गलत किया, 1500 by 50 तो 30 mm, ठीक है। नाउ दिस 30 mm का 20% वी विल सी दैट इज 6 mm। तो इफ अभी तो इसमें सब उस तरह के डेटा आ गए, मैं एक चेंज करता हूं जस्ट, इसको मान लो आप 50 मान लो, ठीक है ना। तो 50 होने से ये डिफरेंस क्या होता है 6 mm। तो एज पर फर्स्ट क्राइटेरिया जो 10 mm का लिमिट था उसके हिसाब से ये काउंट नहीं होता, बट नाउ इफ वी सी दिस 6 mm दिस कैन बी काउंटेड। तो इसमें ये क्या कहता है कि यू हैव टू सी विच इज मोर, दिस 6 mm इज मोर और दिस 10 mm इज मोर, जो ज्यादा है उससे आप कंपेयर करो। तो इस केस में क्या है 6 mm और 10 mm, कौन सा ज्यादा है 10 mm इज मोर, तो we have to check this वर्साइन difference as compared to 10 mm. So again this will not be counted. जो 10 से कम रह गया उसको हम काउंट नहीं करेंगे। अगर यही एवरेज वर्साइन मेरा से आ जाता, एवरेज वर्साइन का 20% से आ जाता 12 mm, then this difference we must have compared with this 12 mm value. ठीक है, मैं कह रहा हूं if 1500 by 50 this become 30 mm and 30 mm का 20% become 6 mm. नाउ अगर शार्पर कर्व होता और एवरेज वर्साइन से रहता मेरा 2 डिग्री कर्व कितना 60 mm के आसपास होता है ना, 2 डिग्री कर्व होता, 2 डिग्री कर्व के केस में 60 mm वर्साइन होता है एवरेज, 60 mm into 20% 12 mm. तो इन दैट केस दिस डिफरेंस इन वर्साइंस शुड हैव बीन कंपेयर्ड विद 12 mm नॉट 10 mm। दोनों में जो ज्यादा है उससे कंपेयर करेंगे, और जिन जिन स्टेशंस पे दीज लिमिट्स इधर दिस और दिस दोनों में जो ज्यादा है उससे कंपेयर करने पे विच स्टेशंस आर क्रॉसिंग दीज लिमिट्स दोज विल बी काउंटेड। इफ इट इज विद इन 20% स्टेशन से इसे 50 स्टेशन का ये कर्व है, 50 into 20% कितना हुआ 10 स्टेशन। तो अगर 10 स्टेशन से ज्यादा लोकेशंस पे दीज लिमिट्स हैव ब्रीच देन वी हैव टू गो फॉर रीअलाइनमेंट, अदरवाइज वी विल डू लोकल रीएडजस्टमेंट ऑफ कर्व। ठीक है, अभी क्लियर है क्या?
Yes, yes. Clear.
फॉर ट्रैक्स स्ट्रेट ट्रैक्स आई मीन कर्व के रीअलाइनमेंट के अलावा बाकी जो भी ट्रैक है रीअलाइनमेंट के पर्पस को छोड़ के, दिस इज द लिमिट, दिस हैज बीन डिसाइडेड, all limits are as per passenger comfort only and for guidance of engineering officials regarding condition of track. Again this is irrespective of any speed band and it says that gauge should be on a straight track between -6 to +6, which was in case of new line up to here, or in fact or sharper curve पे भी 350 मीटर के कर्व पे भी it was -5 to +3 for new track, whereas you can see in maintenance it has been allowed up to -6 to +6 in straight and -6 to +15 in case of up to curve flatter than 4 degree. If curve is sharper than 4 degree then this is +20 mm, which was in case of new track I think +10 mm. So maintenance में limits have been increased, you can appreciate it. Then twist का this is the limit 3.5 mm normal straight track में, and in transition it should not be more than 2.1 millimeter per meter above the designed वर्साइन, design twist, design change of super elevation जो आपने कर्व में डिजाइन किया है ट्रांजिशन पोर्शन के लिए, उसके ऊपर 2.1 से ज्यादा का ट्विस्ट नहीं होना चाहिए। ठीक है, Here it says that if these limits are exceeding, we need not apply maintenance input merely on this ground. We have to see and analyze the last TRC or OMS result and then have to plan for maintenance. That is given in para 525. So floating gauge measurement should not be a basis to disturb or to maintain the track. If anywhere we are crossing these limits, we need to analyze TRC and OMS result of previous run. Then the last tolerance for floating condition is this. You can see it has been laid for 3 speed band, less than up to 45, 30 to 45, less than 30 and then less than 15. This is 30 to 45, this is less than 30, 15 to 30 and this is less than 15. Unevenness on 3.6 meter chord, 22 mm, 22 mm, 24 mm, 33 mm and twist 18, 21, 25. Gauge ka range -10 to +27. So if we are imposing any caution order or special work site pe, we have to maintain track tolerances in these limits only. So to summarize, 4 tolerances under floating conditions are gauge, cross level and alignment in case of new track. Second, existing track के लिए gauge and twist, realignment के लिए, and then fourth is slow down, which is for 3 speed bands, and value of unevenness, twist and gauge have been given. So these are 4 tolerances for floating condition. Then one more tolerance is mentioned, and that is mentioned in machine manual. It is to judge the quality of track machine output, and as per para 224.5F of track machine manual, it says that machine should after tamping be able to achieve track geometry generally to category A standard, but in no case lower than category B limits specified in IRPWM. So this A limit, B limit, C limit was available in IRPWM 2004. 2019 में through ACS 149 and 150 this was taken away, but still track machine manual refers to those limits only. And when we refer when we compare the limits as per these limits given in IRPWM, these are the values we can see. It says that alignment when measured on 7.2 meter chord of a newly maintained track by say tamping machine, the peaks should not increase more than 10 peaks per kilometer, and the desired output should be within ±3 mm in case of alignment. But in any case, peaks more than 10 per kilometer should not be beyond 5 millimeter per kilometer. So इससे खराब हो गया, मतलब we can say that machine is not giving proper output. Twist similarly it says worst case में it should not go below 2.08 millimeter per meter at more than 10 locations. We want this. Machine का desired output should be this. But if it is less than this, means machine is deteriorating my track. It's not improving our track. You can simply say. Unevenness you can see. Desired is +6 mm के peaks. Within +6 mm peaks, exceeding 6 mm peaks should not be more than 10 per kilometer. And in any case, it should not be more than 10 mm. 10 peaks, 10 mm per 10 peaks per kilometer of more than 10 mm. अगर ये हो गया मतलब machine का output non acceptable है. And it says that it should be recorded by the recorder available with the machine. If that recorder is not available, then gauge and cross level will be measured by PWI at every 5th slipper after tamping. ठीक है? Maybe in future this may change, this comparison with A standard or B standard, but right now this is a provision. So I have compared with old standard. This you can see. पुराने PW manual में अगर आप
Sir, one note.
हाँ.
In the last slide.
बोलिए.
Sir, it should be cross level has to be measured at every 5th sleeper. One note is there at the bottom. When then the twist is we can measure only at 3 meter base, but this should be measured at 3.6 meter chord, na?
Twist हाँ इस केस में 3.6 हो जाएगा twist.
But we are measuring at 3 meter, 5 into,
नहीं नहीं ये 3.6
not 3 meter.
इस केस में 3.6 ही है
Fifth sleeper means 4 spacer.
3 meter, but it has to be compared with 3.6 meter, right? But you can calculate this value, millimeter per meter. You can calculate, na?
Okay. Okay.
That will help.
Hmm.
So these were A, B, C, D classification. You can see in old PV manual. Now this is no more available in new PV manual, but पुराने में है, तो उसी से वो compare करके निकाला गया है. Then para 527 that says that what should be safety tolerance, and clearly you can see the stability of train against derailment or safety, you can say, depends on several factors. It includes track geometry, vehicle characteristics, and state of maintenance of both track geometry and vehicle characteristic. Apart from this, operating feature also comes in picture. So, and it clearly says that rail wheel interaction is thus a complex phenomena, and therefore safety tolerance for track alone cannot be prescribed in isolation. So we have not laid down any tolerance. Whatever we have discussed today, no tolerance is for the purpose of deciding that track is unsafe for running the traffic. That is all criteria are for deciding that track is not able to provide desired comfort level. That's all. So no safety tolerance has been given, and these parameters, whenever you are involved in any safety inquiry, any derailment inquiry, please indicate this para, and those tolerances need not be compared with in your inquiry reports. ठीक है? इसके लिए आपको fight करना पड़ेगा. Generally, mechanical people will say that this is the limit; it should be accepted. But you have to show this para. These are for comfort criteria, not for safety. So I have covered all those tolerances. Just you can see the rationale behind tolerances, how tolerances have been fixed, why we need tolerances, what are the action to be taken when tolerances has exceeded, what kind of format is there in case of mechanical measurement for recording the track parameters, and what we have to check after machine tamping. Manual cases में क्या देखना, everything I have covered. If any questions are there, you are welcome, or otherwise we will break now.